Right, so my name's Liz. I work for Aqua Security. You might have met my colleagues Jane and Diego downstairs. If you haven't already, do go and say hi to them. They're lovely. And today I am going to talk about practical steps that you can take to secure containers throughout the CI/CD process. Can I have a little show of hands for everybody who's using containers in production already? Pretty good number of you. Yeah, okay. So when we talk about containers, and we're typically talking about containers under orchestration these days, we have some number of servers, and we're going to be deploying code somewhere on those servers. But under orchestration, we don't really get to control that anymore. All we know is this container image is going to get instantiated somewhere in the deployment. And there could be hundreds of different, let's say they're microservices. This kind of applies if they're not microservices, but for a lot of people who are containers, it goes hand in hand with microservices. So there are a lot of different container images. And then each one of those could have several instances. So we could very easily have thousands of containers running, distributed across the cluster of machines. And they tend to turn over pretty quickly. Datadog did a survey last year that said the average lifetime of a container in production is about 2.5 days, which contrasts with about 23 days for a virtual machine in a kind of traditional deployment. So we've got all these containers running code, and they don't last very long, and we don't really get to control where they're running. So if you're starting from the position of thinking about security from a traditional point of view, it's no wonder that it kind of causes you some headaches to think, well, how am I going to secure all these container instances running all over the place for just a couple of days? And if you feel like that, you are very much not alone. So this survey from last year showed that the vast majority of people agreed that security was something that they were worried about when it came to deploying containers. So there are lots and lots of things you can do to improve the security of your containers. Automation is your friend. With all those thousands of instances, you can't possibly really get on top of that manually. So we're going to have to use automated tools. We're going to have to think about security as part of the automation that we build into, what we've been calling DevOps for a while now. So what I'm going to do this afternoon is show you some practical things that we can do at each different stage of a CI/CD pipeline. You might not want to do all of them. You might want to do all of them. Some of them may or may not be appropriate for you, but I hope that you'll find at least one thing that you can take away and put into your organization when you go back next week. So, super, super simple portrayal of a CI/CD pipeline. We're writing software, we're building it, and then we deploy it somehow into a cloud of machines. So we're going to look at code quality, we're going to look at testing for security, and we're going to look at vulnerability scanning. And all of those kind of aspects will help us try to build artifacts that, as far as we can manage, are free of security defects. Then we're going to look at the security of the hosts we're going to run these containers on. We're going to talk about policies and configuration for those images as we deploy them, with the intention that what we're running is the code that we expected to run with the host configuration that we expected. And then finally, we'll look at what happens in runtime. So once these containers are running, some things we can do to either detect or prevent unexpected anomalous behavior. Okay, so we'll start with the beginning. We'll start with writing code. Security starts with developers. So I'm sure you're all familiar with Bobby tables. Anybody not come across XKCD and Bobby tables? It's probably one of the most famous of the XKCD cartoons. And I did a talk with Justin Cormack from Docker a few months ago, and he built a demo of this. So an implementation of exactly this Bobby tables problem. So I'm just going to bring up, this is a really, really simple web application, and or database application rather, sorry, with a database of student information. And I have a little command to run a query against this web server and query the database. So I just run this, and we find out that Robert is 23 years old. And if we run it again, as I'm sure you all realized, not only did we query that Bobby was 23 years old, but we also did a SQL injection and dropped the students table. So that's SQL injection in action, showing how we can end up losing valuable data if we don't write our code to protect against SQL injection. So how can we tell, what can we do to automate this? We can use static analysis tools. And if I look in my Docker file for this, I've actually got a line here to run a tool called GAS. It's a static analysis tool for Golang. There are all sorts of static analysis tools. What I'm showing here, though, is that you can do this as part of your Docker build step. So if I run this build, Docker build, and at the point where it runs that static analysis tool, it's going to fail. It found the problem, and it's failed that build. So just by building that kind of tooling into the CI/CD build, we can detect issues like that. Static analysis isn't going to find every single possible security defect in your code, so maybe also think about things like code reviewing, peer reviewing. But security does begin with developers, and I think that's a kind of really good example of showing how everybody in the kind of dev and operations and security field need to work together to get secure code. So the next step in our CI/CD pipeline after we've written some code is very often to test that code. And testing doesn't have to just be for functional testing. I'm going to show an example here of doing some security testing. And in particular, we're going to look at testing the encryption libraries being used by a particular application. You might want to do this for regulatory reasons, because everybody loves a bit of EU regulations in a presentation, right? Okay, so if you have to do encryption, and most of you probably do, you could do something like this to test the SSL libraries that you're using. I've got a Docker Compose file here that it just runs an Nginx container, but it also runs this test SSL container, which is going to test the SSL connections or TLS connections that are offered by my Nginx here. So I can just bring up this Docker Compose. It takes a little while here, but it's going to try various different versions of SSL and tell us if there are any problematic versions, anything that perhaps we might want to update in this particular implementation. Talk amongst ourselves for a minute. Okay, now it's started to find, so it's saying, yeah, SSL v2 is no longer considered secure, but it's not offered, so that's a good thing. But SSL v3, which is also not really considered secure, is also offered. So this would be something we'd really want to update in this application. And then we start seeing things like TLS, which it's perfectly happy with. This goes on and on for a few minutes. The point being, you can do security testing as part of your automated testing. You could also do things like performance testing. Testing doesn't have to just be about functional testing. Okay. So we've written our code, we've tested our code, and we want to build some container images. And this is a really great point to do vulnerability scanning. So put up your hands again if you are using containers. Okay, and leave your hands up if you are scanning them for vulnerabilities. Okay, those of you with your hands up, excellent work. Those of you who had your hands up and put them down again, this is something I really think you should do. So vulnerability scanning is looking for known CVEs, known vulnerabilities in the dependencies that you're building into your container images. And again, you may need to do this for regulatory reasons. So if you're having to be PCI compliant, there are actually rules about having to rank the vulnerabilities in your code and having to patch. I'm going to use the word patch because we'll come to that in a second. But make sure that the code you're running has the latest security patches applied. Even if you don't have to comply with things like PCI, the reality is most exploits are due to somebody running some known vulnerability, and then that known vulnerability being exploited. Hello, Equifax. So you really do want to have some kind of process for making sure you're not deploying code with known vulnerabilities. So vulnerability scanning looks at the contents of your container image and looks at all the packages and says, are there any known vulnerabilities? By building into the CI/CD pipeline, we can say, let's fail that build if we find significant issues. You also need to be doing vulnerability scanning on a regular basis because, as I'm sure you all know, new vulnerabilities get found in existing code, in old code. So you could have a library that you build into your images that you've depended on for 3 years, and tomorrow somebody could find an important vulnerability in that. So regular scanning is an important factor. And then it's kind of obvious, but your scanner can only scan the contents of the image that it's looking at. So this takes us to a kind of anti-pattern that hopefully none of you are doing. So you should build your container images and then treat them as immutable. When you run a container, you really don't want that container to be going out and doing, I don't know, apt-get install or something, or even worse, manually SSHing into a container and installing some software. You need to build the container image containing all of the software that it's going to run. If you need to install more software on it, build a new image. Don't update the running container. And the reason why you want to do this is so that you can effectively do vulnerability scanning. You want an image built, scanned, and then that is the software you run in that container. You don't add to it. So if you have a container somewhere and you've identified that it's got a vulnerability in it, we need to rebuild that image concerned and replace that container. So have you all come across the term cattle, not pets? Has anybody not come across the term cattle, not pets? Okay, 1 or 2 hands, so very, very quickly. In the olden days, we used to treat servers a bit like pets. We gave them names, and we looked after them, and we kind of kept them fed and watered. With containers, you need to be treating them more like a herd of cattle. If one of them dies, you can replace it, but you're not emotionally attached. So in exactly the same way, if you find a container, it's got a vulnerability in it, kill the container, rebuild the image, redeploy it. Don't worry about the livelihood of that container. It's gone. So I've talked a bit about how I think you should really be doing vulnerability scanning, and I'm going to introduce Microscanner here, which is a free version of the commercial vulnerability scanner that Aqua provides. So you can all go out and run Microscanner on Monday morning when you go back to the office. And again, like the static analysis tool that I showed, we can build this into the Docker build process and fail if we find a high severity issue. So, what have I got here? Right, so I have a Docker file. This is actually exactly the same as what I just showed on the screen pretty much. And I can build this. There we go. So as part of this build, it's going to run microscanner. I've taken a WordPress image, I've copied the microscanner executable into the container image being built, and then I'm running microscanner inside this container image. You have to register for a token. That's what the token is. And that just sort of prevents people from kind of abusively using this too much. That goes to what we call our cyber center, which is a big database of vulnerabilities. So it fingerprints the contents of the image, sends the fingerprints up to our cyber center at Aqua, and gets back some results. In this particular version, I have asked for human-readable HTML format output, and I've written it into a file. Now, that file, at the end of the build, that file is inside my container image. So I need to instantiate my container so that I can get the file out. And I have a little script to do that. Let's just show you that. So I'm just going to create a version of the container and copy that HTML file out locally, and then remove that container instance. So I'm just going to do that, and I need the ID of the container image I just built. So hopefully, yeah, that's the HTML report that I've just built, and we can open that. And we basically see this particular instance of WordPress doesn't have anything too significant to worry about, no high severity issues, but there are some medium ones. Why can't I? Let's make that bigger. Yeah, there's 3 medium severity issues, and if we wanted to, we could go and find out a little bit more information about those vulnerabilities, and we could figure out either do we want to update, do we need a patch, is this something we're prepared to live with? Either way, we know how many vulnerabilities there are and how serious they are. Microscanner will just automatically fail if it finds a high severity vulnerability, so that can stop your build process, stop you creating an image with high severity vulnerabilities in it. Okay, now I need to find where my presentation has gone. Somewhere. I think it's in this window. There it is. Right. Okay, so if there's one thing that you do as a result of this talk, it's using a vulnerability scanner. And because there are other free and open source tools available, I obviously think this one is good because it uses our commercial database of vulnerabilities, so it's pretty comprehensive. And hopefully you won't get too much in the way of false positives. Okay. We've built some software, we've built these container images, and now we want to deploy them on some hosts. And we need to make sure that those host machines are configured kind of appropriately. Has everybody come across the Center for Internet Security? Anybody not? Okay. So they have some benchmarks that describe best practices for how to install and configure various pieces of software. I think for containers, the 2 most relevant ones are the Docker benchmark and the Kubernetes benchmark. As it happens, I'm a co-author on the Kubernetes one. And the idea here is that it's going to tell you what best practice configuration settings look like for all these different components. You might not agree with all of them. They might not all be correct for your particular environment. So for example, I was speaking to somebody, a product manager from the Google Cloud team, and there are some recommendations in the CIS Kubernetes benchmark that don't really make sense if you're running inside the Google kind of cloud with all the existing kind of networking controls that they have. But as a starting point, to make sure that it's a good idea to test against these benchmarks, and then if you're not compliant, at least understand, well, is there a good reason for that? Now, there are kind of 200-odd pages of tests in the Kubernetes benchmark. So we wrote an open source tool called KubeBench that can run through all of those different tools, all those different tests. And I have a demo of that here. Can I have a show of hands if you're using Kubernetes? Yep, a few of you, okay. So I should be able to run, is this the right? Maybe it's this one. Yeah, here we go. So I should run KubeBench on, does this sometimes. There we go, right, we've got some output. So this is a single node Kubernetes cluster running on a virtual machine on my laptop. And there are a few things that it's found wrong. I just ran the kubelet tests here. And just looking at the first couple of things that have failed, we've got allow privileged. So you probably don't want to allow privileged containers to run in your deployment. The recommendation is don't allow privileged containers. And anonymous auth. So it would be a good idea, in fact, for the kubelet API, it's a very bad idea to let people anonymously connect to the kubelet API, because that's basically like having root privileges. Anyone who can connect to the kubelet API can do anything they like if anonymous authentication is permitted. So both of those things are currently wrong. That's because I've set up my my cluster deliberately badly. And if I look at the running kubelet, so we can see that anonymous auth is currently permitted. So that's one of the things that we just picked up with KubeBench. We've also got allow privileged is permitted. So those are banned settings that I've currently got running. I can use KubeBench to detect those and flag them up for improvement. So running tools like KubeBench can help you identify when you've got insecure settings. And they can also, you can run them on a regular basis to make sure that your host configuration isn't somehow drifting away from what it should be. So we've got our software we want to deploy. We've got some hosts. Now we're going to deploy that software. And this is where you might want to have some image policies. We want to make sure that we're only running the code that we wanted to build. And we might also have some policies for ourselves around the permissions and privileges that containers are allowed to run with. So in Kubernetes, there are admission controllers that can help you police what's allowed, so kind of control what's allowed to be admitted to your Kubernetes cluster. You can also use tools like Aqua to make it easier to manage your image policies. And really what they're doing, whether it's admission controllers that you write yourself or a tool like Aqua, for some definition of bad images, we don't let bad images run on your cluster. So that could be looking at the output of the vulnerability scan. Did that image have high severity vulnerabilities in it? Or did it have particular vulnerabilities that we blacklisted? Did the image get built on an approved base image? A lot of organizations will have like a policy to say, everyone who's writing in Python in our organization should use this base image. And you might want to police that that's actually really the case. You can do that with image policies. It's a really bad idea to build credentials into your container images. There's a lot of different ways in which those credentials might be obtained by somebody who really shouldn't. So we very much advise that you don't put passwords, tokens, credentials directly into a container image, and you might want to police that that is actually the case. Again, with some kind of scanning and then a policy to make sure you're not deploying any images with sensitive credentials in. Image provenance. So I think Colin may have been speaking about this before lunch. You need to know where your images came from. You need to know that the image you deployed is the same as the image that you built and scanned earlier. Again, there are various different tools to help you with this. Aqua is one of those. You may well want to stop people running containers as root. Now, when you run a container, by default, it's going to be root. And root inside the container, again, by default, root inside the container is root on the host. So as a layer of defense, it's a good idea to specify a non-root user if you possibly can, so your container doesn't run as root unless it really needs to. And you also might want to limit the privileges that containers are allowed to run as. And again, this, making sure that you don't deploy a container unless it's going to run as a non-root user, making sure you're not allowed to deploy privileged images. These are things that you can do at the admission control stage. So just because a container says that it wants to have a particular privilege doesn't necessarily mean that's appropriate. You might need to pay attention to the container images that are built and maybe question whether or not they really need to be root, or whether or not they really need the privileges that they've been granted. So I want to show you something that is a way that containers can escalate privileges, kind of rather unintentionally. So I am running as a user called Vagrant at the moment, and if I try to do something like, let's try adding a user, I am not allowed to add a user as Vagrant. Now, if I run a container, I'm just running a normal Nginx container, and I'm going to get a shell into it immediately. And one of the first things you might see is it says I'm root. And that is really root. It's root inside the container. It is also root outside the container. And I can check that that's the case by, for example, if I sleep for a little while inside the container, and I look for the, look for any processes running sleep on the same machine. There it is, and it's root. It's root inside the container, and it's root on the host. They're one and the same thing. Now, the other thing that I did when I started this container was I mounted the etc. directory from the host into the container. So it's accessible as /etc from inside the container. So now I could do adding a user because I'm root and I have access to etc. And let's see if I can type in a password. So I've created a user that I wasn't previously allowed to do. Just by virtue of running a container, I have escalated my privileges to the point where I can create a new user. So now if I can now log in as that user that I've just created. I wouldn't have been able to do that if I hadn't had a container. And I wouldn't have been able to do the real point where we leaked privilege or leaked something really important was by mounting /etc, which is sensitive because it contains our password database. So this is an example of why you need to be careful about things like bind mounts like this, directory mounts, and why if I wasn't running as root, I still wouldn't have been able to do this because I wouldn't have had permission to create a new user. So it's an example of how you may inadvertently have more privileges inside the containers that are running in your deployment than you realize. Minimizing the extent to which people can mount directories from the host into the container. Explicitly setting a non-root user by using the user command in the Docker file. And at all costs, don't set the privileged flag. Unless you really, really know that you need the privileged flag, don't set it. You almost certainly don't need it. And all of those things will help you minimize the extent to which your containers just automatically escalate privileges. So the final step, we've built our software, we're running it on some hosts, it's running. Now that we can start thinking about monitoring or observing that running software and checking whether it's behaving the way we expect it to behave. So if we talk about a microservice, say, for example, we're talking about a product search microservice, we can reason very easily about what it should be allowed to do. Product search should be allowed to make requests of a product database. Probably shouldn't be going to the external internet. Probably shouldn't be running, I don't know, commands like useradd, for example. So lots of things we can say any given microservice really shouldn't be doing. You can use tools like seccomp or AppArmor or also SE Linux to restrict the behavior that a container is allowed to do. You can apply a seccomp or AppArmor profile to any given running container. So you might have a different profile for each different container, or more commonly, you might want to use the default Docker profiles. Jess Frizzell did a really great job of defining a default seccomp profile that restricts the system calls that containers can use to a very sensible set of defaults that kind of allow 99.whatever% of containers to operate as expected, but prevent some crazy things that no container really has any business doing. So the default Docker profiles are a really sensible place to start, particularly if you don't know better. If you don't have a better profile in place, these are good to use. But if you're using Kubernetes, they don't automatically get applied, which when I first found out was quite a surprise to me but it was using Docker as the runtime, so wouldn't it? No, it doesn't automatically pick them up. You have to explicitly specify the Docker seccomp and AppArmor profiles in annotations, like I've done here in a pod security policy. So this is another really small but useful thing that you might want to do if you're running Kubernetes. Now, you might want to take it a step further and use a tool like Aqua that can limit container activity on a kind of more granular basis. So we can restrict a container to only running a certain set of executables, maybe only running as a particular user ID or a set of user IDs, knowing which network traffic should be permitted, what IP addresses, what DNS names, what other services should that container be allowed to access. Now, if a container does something out of the ordinary, it could be a bug, it could be malicious behavior. It's almost certainly not something you want to, well, you almost certainly want to know about it, so getting a log for it is a good thing, and perhaps you want to prevent it from happening altogether. So, my last demo, let's see whether or not I've got, okay, I've just got Aqua running. So I'm going to run an Nginx container, and that's running, and I'm also going to show you, so this is a bit of the Aqua console, and I can see running containers. This is my Nginx that I've just started running. And it's running with a profile called Nginx October 2018, and I can look at the settings for that. It's currently in audit-only mode, and it's going to say the only executable that I expect to be able to run is Nginx. Nginx doesn't need to do anything else. It just runs Nginx. So anything outside of that behavior is unexpected. Now, I just ran it and got a shell into it, so I could do things like, who am I? Maybe list the contents of the root directory. Probably not something that we want to see happening inside an Nginx container in production. If I go to my audit log, it's basically spotted that. There's the ls that I just ran. Maybe this will be, that's also ls. This is going to be the who am I. So we've detected unauthorized behavior, something unexpected, something that was outside of the expected profile for Nginx. I could also go back to that profile, if I find the right one, Nginx October 2018, and put it into enforce mode, and save it. And now, I'm going to get permission denied. So we can actually lock it down and prevent anything outside of that expected behavior from being run. In fact, if I stop this container and try to restart it, that's not allowed because I tried to run bash. And that is not part of the expected profile, and I've got it in enforce mode. And if I go back to my audit log, we should see some, let's see what we've got here. Yeah, there's the bash command being blocked. So that's like a really powerful way of locking down behavior on a kind of, on the basis of what container image is running. And if you want to know more about that, please go and see my colleagues downstairs. So we've looked at something you can do at every stage of the CI/CD pipeline. We've looked at using things like static analysis and code review to review for security issues at code time. We've talked about the possibility of security testing, vulnerability scanning. That is my, the single thing I want you to take away. If you're not already doing vulnerability scanning, that could really save your ass. Host configuration, checking that your hosts are configured according to best practices, and maybe using tools like Kubebench. Making sure that you deploy containers with appropriate rules around them, looking for things like minimizing privileges, minimizing bind mounts. And then finally, things like seccomp, app armor profiles, or commercial tooling to help you ensure that containers only do what they are supposed to do and don't do anything unexpected. I think that's pretty much sensible advice. You might disagree. Up to you. And finally, I was very excited because today was the first time I saw physical copies of a book that I've just recently co-authored with Michael Hausenblast from Red Hat. So we still have a few more copies of it downstairs on the Aqua booth, and you can also download it from the Aqua site, download an e-copy. And finally, if you want to use any of those tools that I mentioned, Microscanner, Kubebench, they're available on GitHub. And you can find the demos that I ran, some of them that were put together by Justin, as I mentioned. They're on this No Meltdown GitHub repo. I think I've managed to stop with about 35 seconds left for a very, very quick question. Or just 35 seconds of rapturous applause is also okay. Thank you. One question, maybe? Any questions? Okay. Okay, thank you very much.